Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify reaction pathway to P and question. CH3-CH is equal to CH2 undergoes hydroboration oxidation, BH3THF then H2O2O. This is an anti-Markovnikov addition of water, placing the O on the terminal, less substituted, carbon. Product P is equal to CH3, CH2, CH2, O, propan 1-ol, a primary alcohol. PCC oxidize primary alcohols to aldehydes without overoxidizing to carboxylic acids. So Q is equal to CH3, CH2, CHO, propanol, an aldehyde. Moving on to the next step. Identify reaction pathway to R and S. CH3-CH is equal to CH2 undergoes oxymercuration-demercuration, HgOAc, to H2O then NaBH4HO. This is Markovnikov addition of water, placing the O on the more substituted internal carbon. Product R is equal to CH3-CH or CH3, propan 2-ol, a secondary alcohol. PCC oxidize secondary alcohols to ketones. So S is equal to CH3, CH3, propanone acetone, a ketone. Moving on to the next step. Q is equal to CH3-CH2 CHO, propanol, molecular formula C3H6O. S is equal to CH3-CH3, propanone acetone, molecular formula C3H6O. Both Q and S have the same molecular formula, C3H6O, but differ in the nature of the functional group. Q is an aldehyde and S is a ketone. Compounds with the same molecular formula but different functional groups are functional isomers. And for the final step. A. Positional isomers differ in the position of the same functional group on the same carbon skeleton. Q and S have different functional groups, so not positional isomers. B. Chain isomers differ in the carbon skeleton arrangement. Both have the same straight 3-carbon chain, so not chain isomers. C. Stereoisomers have the same connectivity but differ in spatial arrangement. Q and S have different functional groups and connectivity, so not stereoisomers. Therefore, the correct answer is D. Therefore, the correct answer is option D.